In this lesson, we're going to take a look at some OSPF operational commands on Arista switches. We'll include looking at our running configuration and some commands related to MTU, using ECMP to influence the number of paths we have in our routing table, as well as manipulating the administrative distance. The command show IP OSPF interface is useful in verifying not only that OSPF is running on an interface, but also to verify the various interface related settings. Show IP OSPF interface, enter. And here you can see on this switch, interface Ethernet 3, 4, and 5 are all running OSPF. We can see our interface address, our VRF, the area that this interface is in, our network type and cost, as well as the hello and dead intervals, and whether or not we have authentication enabled. If you suspect a multi-vendor interoperability issue, then not only will checking the logs help, but also the command show IP OSPF, enter. The output of this command provides a bunch of useful information, including the areas that we're in, the interfaces associated to those areas, and the amount of neighbors that we have. A topic that may be a surprise to some folks is MTU, or Maximum Transmission Unit. While there is a well-known list of items that must match during the OSPF Hello protocol exchange, for instance, the subnet, the area ID, authentication, among others, MTU must also match on the interface between the potential neighboring OSPF devices. You should refer to John Moy's book, OSPF, Anatomy of an Internet Routing Protocol. In that book, he explains the issues they noticed when first developing OSPF in regards to the exchange of the linked state database descriptor packets. These problems arose because of the various underlying topologies that were available at the time, including FIDI, token ring, frame relay, serial interfaces, and Ethernet interfaces. So to help deal with the multitude of topology options and speed up the database descriptor exchange, they determined it would be best for both potential neighbors to use a matching MTU. So if you see the output of your show IP OSPF neighbor command, where one neighbor is stuck at exchange, the issue could be a mismatched MTU setting. Let's demonstrate this between switch 4 and switch 5 in our lab. So here on switch 4, let's take a look at the interface going to switch 5. Show interface Ethernet 5. And on that interface, you can see that our MTU is currently set to 1500 bytes. And we'll verify that we have OSPF neighbors established. Show IP OSPF neighbor, enter. And you can see that this switch has 3 OSPF neighbors, 0.2, 0.1, and 0.5. And 0.5 is our switch 5. So now let's log into switch 5 and look at his interface Ethernet 4, which is the one that connects back to this switch. Show interface Ethernet 4, enter. And here you can see he has a matching MTU, 1500 bytes. And show IP OSPF neighbor shows that he has 2 neighbors established, the 0.3 and the 0.4. And 0.4 is our switch 4. So now let's change the MTU to something in the jumbo frame range. So config, enter, interface Ethernet 4, enter, MTU question mark, and we can see the range options for our MTU. So let's change this to 9214 and hit enter. And then let's verify our configuration change with the show run interface Ethernet 4, enter. And under our configuration there, you can see our MTU is now set to 9214. We can also verify that with a show interface Ethernet 4 command. And in the output of that command, again, we can see our MTU is set to 9214. And now if we look at the OSPF neighbors with the show IP OSPF neighbor command, we'll see that the connection to 0.4 from a neighbor standpoint is stuck in exchange. We can't make it to full. And if we see what's in our logs, we can drill right into the OSPF with show logging pipe grep and then -I to ignore case and OSPF, enter. And in that output, we can see we have an OSPF warning MTU mismatch, where his is 1500 and mine is 9214. Thankfully, the logging's verbose and helps determine what the problem is. So let's fix it by matching the MTU back to 1500 bytes. Again, we're still in interface Ethernet 4, so here we could simply type MTU 1500, enter. And then a show run interface Ethernet 4. We see that our MTU 9200 is gone, and then show interface Ethernet 4, we can see our MTU is 1500 bytes. And then finally show IP OSPF neighbor, and we can see we're back to a full state with switch 4. So keep an eye out for getting stuck in exchange and MTU mismatches. The next topic to review is multiple paths for OSPF. On Arista switches, we get to take advantage of ECMP, equal cost multipath, where we can enable ECMP, which is to say that we can define up to an X number of paths that we'd like calculated and added to the routing table as appropriate on a per flow load sharing basis. And it's simple to implement. Config, enter, router OSPF1, enter, and then here if we type maximum dash pass and question mark, we can see the maximum number of next hops on this particular platform is between 1 and 32. So we just simply type 4 and hit enter. And then we can verify our configuration with show run section router OSPF, enter. We can see at the bottom of that output our maximum paths of 4. We can also issue the command show IP OSPF, enter, and see that there's a line here where we've configured the maximum number of next hops supported in ECMP is 4. And the last topic for this section is administrative distance. Arista provides administrative distance to help us choose between multiple routes when those routes are of the same prefix length and are learned via multiple methods, such as OSPF versus BGP versus static routes. Arista's implementation of administrative distance uses a default AD of 110 for all OSPF routes. Keep in mind that administrative distance is only locally significant to the switch. We can change the AD for the OSPF routes with the distance command in router OSPF configuration. So let's exit this switch and go to switch 1. Show IP OSPF neighbor. He has one neighbor, and then show IP route. And we can see we have connected routes and OSPF routes. And notice that all the OSPF routes currently have an administrative distance of 110, regardless if that route's an intra-area route or an inter-area route. So let's change that. Let's get into config mode by typing config, enter, and then router OSPF1, enter. And then here the command is distance, space, OSPF, space, and if we put in a question mark, we can see that we have the options to influence the AD of either our external routes, our inter-area routes, or our intra-area routes. Let's change our intra-area route AD. So we'll type intra-area and then question mark, and we can see the administrative distance value range is from 1 to 255. So let's use 101, enter, and then verify our change with the show run section router OSPF, enter. And in the output, right near the top, we can see our distance OSPF for intra-area routes is now 101. And then we can reissue the route table command, show IP route, and specifically OSPF, enter. And now we can see that our inter-area routes are still 110, but our intra-area routes are now 101. And that's only locally significant to this switch. If you're manipulating the administrative distance in a production network, be sure to give some thought to whether that change should be made on all devices in the network.